Good evening to all. Today we are going to discuss about the second topic of your second unit, bipolar junction transistor. So already we have discussed fully about your transistor operation. It's how it is constructed both for NPN and PNP transistor, right? So today we are going to discuss about this transistor biasing topic. So in this transistor biasing topic, we are going to discuss how it should be, what is the necessity for this transistor biasing, and what is transistor biasing, and how we are going to bias the NPN and PNP transistor. Okay, so transistor biasing, what is it means? Bias, whatever. So for example, if you want to do anything, you should need some external and force, right? Similarly, the transistor circuits to amplify a signal, it should be given with an external supply. It will be provided with an external DC voltage. So transistor biasing is the process of setting the transistor DC voltage to the correct level for the amplification. To the correct level for the amplification. So that is nothing but your transistor biasing. So in order to obtain that, you will be to make your transistor to operate as a linear amplifier, it should be properly biased. So the N-type material is provided with negative supply and P-type material is given positive supply, means we know this is forward biasing. Similarly, N-type material is provided positive supply and P-type to negative supply, means it will be called as the reverse biases. These things we have discussed in the PN junction diode, right? So similarly, we discussed that transistor is having three terminals, right? One is the emitter. In this, the first two terminals will be forward biased. The first two will be forward biased, and the second emitter and collector should be reverse biased to operate the transistor. So it is always forward biased to make the emitter current to flow through the base, and it is getting to the collector. Similarly, the collector base junction should be reverse biased. Okay, so these are the two things you have to remember in discussing this transistor biasing. All the emitter current which is generated due to the external supply will be flowing through the collector circuit and gets collected. PNP and NPN transistor are connected. So PNP transistor. So for this emitter base junction should be forward biased, so that the P type should be connected in the reverse bias, right? Should be connected to the negative, opposite. Similarly, it should be connected to the negative condition. Okay. Then we are going to see this transistor biasing for NPN transistor, means N to negative and N to no. So this is reverse bias and this should be forward bias. Okay. So which will be giving the condition for biasing. Similarly, the same thing I'll represent it with the transistor symbol. This is the symbol for the PNP transistor. The emitter current flows the opposite direction. So it represents NPN transistor, right? So this how it is biased, we have shown with the diagram. So in order to make this, if the particular emitter based junction is forward biased and the collector based junction is reverse biased, then the transistor will be acting as an amplifier. Okay, so there are three operating conditions based on this. One is region. So both the junctions forward bias means it will be acting as a switch. Transistor will be acting as a switch. It is a closed switch. And if both the junctions reverse bias, means the region of operation is called as cutoff region, it will be acting as an open switch. And if both the junctions, one of the junction is forward biased, the other junction is reverse biased, that is nothing but your transistor to be made to be in this mode only. We are going to make the transistor to conduct or operate. So that is, it will be acting as an amplifier. So based on this biasing condition, there are three operating regions: saturation region, cutoff region, and active region. These are the conditions in which, so while going for the transistor can act as a switch as well as amplifier. It will be acting as a switch when both the junctions are forward biased and the reverse biased. And if the emitter based junction is forward biased, it will be acting as an active region, and collector based junction should be reverse biased. Okay, that will be considered to be the amplification of the transistor. This is about your transistor biasing. Okay. Thank you.